Okay, so here we have a very nice question where we basically say that x1, x2, x3 are all terms of a geometric progression. So let's say x1 equal to a, so x2 should be equal to ar, so x3 should be equal to ar square, and so on. So we have totally how many terms? Please observe, this is the n minus 1th term. Okay, so if I take up to n minus 1 terms, I should be getting 2 power n minus 1, which basically means if I take p terms, I should be getting 2 power p minus 1. I'm just making it less confusing. I'm just explaining to you. I'm taking out n so that it is less confusing, because n minus 1, there are too many unnecessary things. Basically, the logic is, if you take p terms on the left hand side, the right hand side should be 2 power p minus 1. Now, you can find this sum to infinite, that is a plus ar plus up to infinity, only if you know the value of a, because r is given to you. Now, to get the value of a, you need to use the equation here. So instead of generally expanding this in terms of n or p number of terms, take one term and see what happens. If p is 1, if you take only one term, if p equal to 1, then what happens? You get the first term on the left hand side, x1 minus x2, and the right hand side becomes 2 power p, which is 2 power 1 minus 1. Correct? So this is 1. So 1 by a minus ar equal to 1, right? So here I'll take 1 by a into 1 minus r, which is equal to 1. So this becomes 1 by a. Now 1 minus r is 1 by 2, so this becomes 2 by a is equal to 1, or a equal to 2. That's it. So once you get a equal to 2, you know the infinite term. What is happening? It is 2 plus 2 by 2 plus 2 by 2 square plus and so on, because r is 1 by 2. So this total, if you want, sum of infinite progression is a by 1 minus r. Okay, so this a is 2 by 1 minus 1 by 2. So 2 by 1 by 2, which is 4. That is option B. So if you try to solve this using n, it becomes very complicated. You can just look at one term or two terms and then you'll get your answer.